Welcome to the DIY Honda Garage channel. DTC P154A indicates a battery sensor internal failure, a significant issue affecting the vehicle's battery management system. This code points specifically to a malfunction within the battery sensor itself, rather than issues with the battery or the charging system. It's crucial to understand that the battery sensor is responsible for monitoring the voltage and current of the vehicle's battery, which is vital for optimizing electrical consumption and ensuring effective battery performance. Located near the battery, this sensor communicates vital information to the Powertrain Control Module, PCM, for analysis and decision-making. The PCM, which is an integral component of a vehicle's engine management system, uses data from various sensors to adjust engine parameters, thereby optimizing performance. Proper functioning of the battery sensor ensures the reliability and longevity of the vehicle's battery, making it essential to address any issues promptly to avoid potential vehicle failures. The DTC P154A signifies that there is an internal failure within the battery sensor of the Honda Accord, specifically from the model years 2017 to 2023. This battery sensor, crucial for monitoring the condition and performance of the battery, is physically located near the vehicle's battery. Its main role is to relay data regarding voltage and current flow to the Powertrain Control Module, PCM, helping to maintain optimal battery performance. An internal failure in this sensor may lead to inaccurate readings, affecting electrical system effectiveness and potentially causing other system malfunctions. Proper operation of the battery sensor is necessary to ensure effective battery management, including charging and overall life expectancy. An awareness of this error is vital to addressing any potential issues early in order to prevent further complications. Several possible causes can trigger DTC P154A. The most direct cause is an internal failure of the battery sensor itself, which might occur due to wear or manufacturing defects. Another significant factor could be poor connections or loose terminals at the battery sensor and the PCM. When connections are compromised, it can lead to inaccurate data being sent to the PCM, causing fault codes. Additionally, the wiring connected to the battery sensor may suffer damage or faults, leading to electrical issues. Finally, checks need to be performed on the fuses, as any blown fuses related to the battery sensor could result in operational failures. Each of these causes must be meticulously examined during diagnostic procedures to determine the exact source of the fault. When DTC P154A is activated, certain symptoms may manifest, indicating underlying issues. One common symptom is the illumination of warning lights on the dashboard, particularly those related to battery performance. Drivers may notice fluctuations in battery performance, such as reduced cranking power or delayed starts, which suggests the battery may not be receiving accurate readings from its sensor. There might also be erratic behavior in electrical components, as improper voltage regulation leads to performance variations. In some cases, drivers may experience difficulties starting the vehicle altogether, which can be alarming and inconvenient. Recognizing these symptoms early enables proactive measures to prevent more severe complications, ensuring reliable vehicle operation. The first step in troubleshooting DTC P154A involves confirming the error by using the Honda Diagnostic System, HDS. Begin by turning the vehicle to the on mode, which powers up the instruments without starting the engine. Next, use the HDS to clear any existing DTCs. This step is crucial as it resets the system, allowing it to re-evaluate the battery sensor's performance. After clearing the codes, switch the vehicle back to the off mode and wait approximately 5 seconds to allow the systems to fully shut down. Once this time has elapsed, turn the vehicle back to the on mode and again, use the HDS to check for any pending or confirmed DTCs. If DTC P154A is indicated once again, this confirms the issue, allowing you to proceed to the next step in the troubleshooting process. If it does not appear, it indicates an intermittent issue that may require further investigation. In this second troubleshooting step for DTC P154A, the goal is to pinpoint the possible failure area. First, ensure the vehicle is in the off or lock mode. After ensuring this, proceed to disconnect the 12-volt battery sensor 3P connector. This model's configuration includes two specific test points labeled for the evaluation process. With the connector disconnected, measure the voltage between these designated test points. Specifically, test point 1 will be the female terminal number 1 of the battery sensor connector, while test point 2 should connect to the body ground. The vehicle must remain in the off state during this measurement to ensure accurate readings. If battery voltage is detected, this indicates that the wiring and connection to the battery sensor is functioning properly, suggesting a replacement of the sensor itself is necessary. Conversely, if no voltage is found, this indicates that further testing is required. Moving on to the next step, the final troubleshooting step for DTC P154A involves checking the specific fuse related to the battery sensor. Focus on fuse number A16, as it plays a critical role in maintaining the electrical circuit connected to the battery sensor. This step requires assessing if the fuse is intact or has blown. If the fuse is operational, the next action is to check for any open circuits in the BAT-IR wire that runs between the 12-volt battery sensor and this specific fuse. If repairs are necessary, diligent inspection must be applied to ensure continuity in the electrical path. If the fuse is found to be blown, this could signify a short circuit within the same wiring, needing immediate attention. In this scenario, both the BAT-IR wire and the fuse number A16 should be repaired or replaced to restore proper functionality to the battery sensor system. Addressing both possibilities helps resolve the detected faults effectively. After completing all repairs related to DTC P154A, it is essential to perform a final verification to confirm the faults have been rectified. Begin by testing the battery sensor system to ensure everything operates as intended. Using the HDS, clear any DTCs that have been logged during the earlier troubleshooting steps. This action resets the system and allows it to start fresh, checking for any recurring codes. Following this, conduct a thorough observation of the system's operation. Pay close attention to any dashboard warning lights and ensure there are no issues with starting the vehicle or with electrical components. Successful verification means the repairs undertaken have addressed the underlying issues effectively, confirming that the battery sensor is functioning properly and the vehicle is now fully operational. To prevent recurring issues related to DTC P150A, a strict preventive maintenance routine should be established. One of the key aspects is regularly checking the battery connections to ensure they are secure and free from corrosion. Corroded or loose connections can lead to inaccurate readings and potential failure of the battery sensor. Additionally, it is vital to inspect the wiring associated with the battery sensor periodically for any signs of damage, wear, or fraying, as these problems can lead to shorts or continuity issues. Alongside this physical inspection, testing the battery sensor's functionality at regular intervals can help identify any early signs of failure before they manifest into trouble codes. By implementing this proactive approach, the longevity of the battery and its related components can be significantly improved, avoiding costly repairs and unexpected breakdowns. DTC P154A highlights a critical failure within the battery sensor, which impacts the overall performance and reliability of the vehicle's electrical system. Understanding this fault code emphasizes the importance of recognizing symptoms early and addressing issues swiftly to maintain vehicle performance. The troubleshooting process must be meticulous, encompassing verification, measurement, and component testing to ensure complete resolution of any faults. By adhering to a thorough maintenance schedule, vehicle owners can safeguard against future issues related to battery management. Regular checks and preventive measures will help prolong the lifespan of not only the battery sensor, but also the vehicle's electrical system as a whole, ensuring a smooth and reliable driving experience for the owner. Please like and subscribe to the channel. See you next time.